Data is the new oil. I think that's a saying that goes back to at least 2016, I want to say, when an article in the New Yorker basically made this assumption that data is something that is still in a very raw form, but something that you want to kind of amass, something that you want to get a lot of, something that in the end will fuel our planes, fuel our cars, that will enable us to get from place A to B, so something that in the end really means money, means wealth, means things that are really good. In the past years or year, the meaning of oil has changed, I think, more drastically than in the past decade. Oil is not associated anymore with good things, wealth, but more so with something that is not sustainable, not something renewable, something that you rather want less of than more, something you want to substitute with renewable energy. You want rather electrically powered cars than the traditional diesel-powered ones, and something, you just want to have less of. And I think the metaphor might still hold, because when looking at data, it's basically something maybe you do not want as much of it as you're currently having. Looking at the raw numbers, 200 terawatt hours, that's the energy that's consumed in a year by all the data centers worldwide. And if you take that number and translate it into the CO2 equivalents, so basically what it means in CO2, then it's a little bit more than the entire airplane industry combined. So rather large number. And in the end, this basically means, okay, we are at a point where we might want to think about less consumption. And looking at another picture, this wave here, this wave of information, this wave of digital stuff, we had in the industrial space a lot of, or some information in the beginning, so not so much in the first wave, a little bit more in the second wave. In the third age, okay, we are at PLCs, so a little bit information, and now we're at the fourth stage. But we are at the beginning of the fourth stage. So we are there where industrial IoT solutions take up, where AR, VR has taken its place in this whole economy, and it's still at the beginning. So looking at the data, it is still something where it's going to be probably a lot more of in the future. And this is kind of the scary thing about it, because if we are now looking at something that already has as much energy as the entire airplane industry, how much is it going to be at the end of this wave? And that's the reason why you already heard what we at Wattix are doing. We're basically building startups, and these startups have just a variety of different applications. You can imagine that the online healthy food store has very much different data, use cases, and kind of things you need to know than the industrial IoT solution that basically gets data from machines that are in process. But still, we, on a daily basis, need to have some sort of guidelines and rules to work with it, because our daily job has two faces, so to say. On the one hand, we are engineering these solutions, so we are building these solutions for the online health store or for the industrial IoT equipment if they are still in an early phase, MVP, pre-product market fit, on the one hand side. And on the other hand side, we are working with our existing portfolio companies to kind of help them shape their product and bring them to the next level. And these two combined basically make up our daily lives. And that's why we had to have really simple rules to kind of tackle this problem and look a little bit more deeply into it. And we came up with basically 3 points that are very easy to remember: eliminate, utilize, and allocate. And I'll go through each and every one of them to just simply show you what you can do in this respective area. So at the eliminate stage, Around 70 to 90% of the data is assumed to be so-called dark data. Dark data means this data won't ever get used. No front end will ever see it. It's just lying in some sort of back-end system that is just there. And this kind of data is something that is still consuming energy, that still has to be provided or could be provided in some sort of way, so still is consuming something. Basically, there are three different categories in which this data usually occurs. First of all is backups. Backups take a lot of space. And if you think about backups, you need to think really through if the policies that you set, I hope you have set policies, if they are good, then, or if they fit what you're actually doing. So if you are, for example, in the financial industry, it might make sense to have like hourly full backups because you're in a highly regulated market and you really need to see and be able to roll everything back and show to auditors where you're heading. But if you're not in this industry, maybe it makes sense to just have a very simpler form. Maybe just retain daily data for a month and then spread the interval and not full backups, but just incremental ones. And these are just like the simple steps that you can take. So you can get rid of a lot of backups. Of course, not all of them. Please do not get rid of all backups. But basically, backups is one point. Another very important point is duplicate data. Duplicate data means we have the similar data in several spots. When we looked at one company, we found that about 30% of their entire data was just duplicates. So duplicates, mainly the bigger ones are videos usually, or CAD files in this case. It was a manufacturing company, and this data just takes up a lot of stuff that you can easily get rid of. And the third category is generated data. So generated data, if you upload, for example, an image, you know that you're going to spread it into different resolutions to be able to serve all of your end devices and to show the respective users everything. In this case, you usually also do too much of these like pre-provisioned images. That's one of the cases where the user interface maybe does not see what's in the backend. So, for example, you only have like one target size. You're just targeting like desktops with a certain resolution, and you do not need like from icon size to large size every kind of image that is being generated. So, really look into these cases if you apply a one-fits-all policy, if it's really necessary to generate all of this data. And one like additional fourth category in this, but which is rather on a like managerial level, CCing. CCing people in especially larger organizations. You can just get rid of CCing most of the time, but it's still something that happens much too often. Continuing with the utilized category. The Pareto effect, basically the 20-80 rule says you can do 20 of X, which leads to 80% of Y. So 20% of the effort that you put into it leads to 80% of the outcome. 20% of the data that you use for your AI models gets you to 80% accuracy. And in this case, you always have to think about, is my use case really these 99.99% accuracy that I need, or am I fine maybe with 80% because it's just going to be a predetermination where I stand and not so much if it's really accurate. Two speakers at least that I've encountered also play into this card. So I think, to quote Eleanor, data is gold, but too much will weigh you down. So that's one of the things that also Sangeeta says. Really think about if you need all of these data, but or if you can get through with about 20% according to the Pareto principle. So in the utilized category, always think about what you already have before acquiring new ones. So think about all the data that's already there and not, okay, I need this specific sensor value as well, and I need to do this case to get further. Database is another category in the utilized category. So databases sometimes are also quite hip, or certain hip databases are chosen for specific use cases. There, always think through if maybe the traditional ones that might consume less energy, that might be more efficient, are maybe the better choice than using the most hip database out there that may lead to a lot of duplication or a lot of more data in your data store than necessary. And the third category is allocate. Allocate means basically provisioning, only really choose what you need and choose your locations wisely. Try to set every server, every single instance that you have to a level that fits your application. Especially in the area of like ops or FinOps, to be more exact. So financial ops is an emerging, or has been an emerging topic, I think, in the past 2 years, where specific departments, consultancies look at all the different cloud sources that you have and see whether they make sense and whether they could be scaled down in order to save money. Very simple. A lot of these have been relabeled quite recently to be so-called green ops. Green ops meaning, we are green. The thing is, basically, both principles can be applied. So if you scale down your compute resources, if you use less CPU power, then this is going to have a benefit on the bottom line, on the financial side, as much as it's going to have an effect on the ecological side. So basically, win-win for both sides. But it's not only that; it's basically looking very deeply into your resources. You can do this quite easily if you're using any of the cloud providers, Google, Azure, AWS, preferably really in that order, because that's how that's the order in how energy efficient or how green their respective clusters are. Each of them will have this dashboard where it really dives into what kind of carbon efficiency you're getting. This is just one like smaller project where you can see which energy is consumed by which kind of computing resource. And this is basically your very simple starting point that you can use as an entry to get even deeper. And you can start, of course, in this case, probably with the Kubernetes engine and then work your way downwards. When thinking about it, about provisioning and allocating your data, don't only think about the size, also think about location. Location, on the one hand side, be always close to your customer, because closeness to customer leads to less transition in energy in between, so different networks that need to be accessed. But on the other hand, also try to choose regions that are the most energy efficient in your respective cloud provider. If you're just like freely, if you're just would be just choosing a location independently of that, you probably would, for example, go to Iceland, because Iceland, on the one hand, has a lot of like these green cloud providers or green energy providers, and on the other hand, the whole grid is green. This is an important factor which you can also see in the better examples of the cloud providers, like in here, that not only the CFE, so the carbon-free energy percentage, is a factor to be looked at, but also the surrounding grid. So for this Google example, you might, for example, choose Belgium as one of the closest ones to here, because it's almost as close to all of Germany as Frankfurt and has a much better CFE than Frankfurt, and even lower grid carbon intensity. So these are basically the 3 rules that, of course, you can dig a lot deeper, and you can try to educate yourselves upon even further. But these are the 3 simple rules you need to transport. For you today, basically, as engineering managers, as leads, as tech leads, there's like a 4th thing I want to mention, and this is basically educate. This could be or should be maybe your main job in this whole area. Educate, teach and learn, and we all know that learn is just some sort of simple substitute for implementing some sort of process, because no one likes process, but learning is fine. And yeah, learning is one of the most important aspects to dig deeper into. How did we do that at WhatX? Very first simple starting point, create a checklist. Product managers, project managers love checklists, and engineers are fine with like checking boxes. So this is this is basically also the separation in this checklist. So the first thing in here is setting the surrounding environment or setting the targets, talking really or specifying exactly what kind of environment you're tackling, because tackling the environment or looking at the environment already has a huge influence on what you're going to do later. Setting that, just to give like 2 examples out of this list. The first example would be to for example, look at the platforms you're targeting. Platforms you're targeting, you might just say, okay, I'm just going to target iOS, the latest version. That is fine. I'm just going to, I just need the hippest users out there, and this is going to be okay. But think again, do you really want a user that wants to use your app to buy a new iPhone just to use it? Because, I mean, your app might be the next Clubhouse or something. And do you really want them to have to upgrade their phone, or would it be okay for you to go a little bit deeper in that, to really see, okay, yeah, I can take on older versions, I can tackle them, and then your users don't have to get a new iPhone, and less waste is produced in the end. Another example in this is really looking at the distribution and scaling of your users. So do you really need to start with this like whole Kubernetes clusters across region, multiple redundancy, whatever the scaling is about? Or is it fine to just start a little bit smaller? Because you can still like scale up, but you're going to start in the first year with only 1,000 users anyway, because you want to do some sort of trial phase for something. Then this might be fine as well. The second part of the checklist is really about the tech behind it, and separated into 3 larger parts: infrastructure, back-end, and front-end. So all of the different domains, because all of them can contribute. Even more can contribute. So product management can contribute, design can contribute. But from the tech side, it's basically these 3, and all of them can have an effect. And once you have implemented, once you've started thinking about this in a larger role, the next thing you need to do is talk more about it. In our case, we have these like regular talks, or so-called WhatX Insight sessions, where we discuss internally with our portfolio companies, and sometimes even open to the public a lot of different domains. In this case, for example, building sustainable digital products. So not only about how to build them in a sustainable way, but really thinking about what could be a new business model for an existing one to drive sustainability. So to give an example, a company that is usually helping users to save money by logging all of their credit card activity and then giving them advice on this could think about a potential sustainable solution by using the same data to help them save energy. So for example, it sees that they are consuming a lot of meat because they are going always to the butcher. It might suggest maybe choose a healthier lifestyle. Or they see that they are driving a lot of cars. So it might suggest also to kind of adapt the lifestyle in this sense. So this might be like a new business case for an existing company that is even targeting this solution. And of course, this is going far beyond the real like engineering of things, but this is also the things that need to be talked about within an entire company. And tech is definitely one of them. And to again quote one of the earlier talks, in this case, Nelida, who said, advocate with conviction, really talk about, really dig yourself deeply into this and then be able to talk about it in a manner that can convince people and that takes people with you. The next thing that you can do as a company or should do as a company is discussion. So really take the time to discuss topics intensely. And I'm going to provide a small example of what this can look like, but it can go. You can basically, or you should pick a topic that everyone is familiar with. Best case scenario, you've already like seen a certain area within your code, within your infrastructure that you want to talk about, but there are also just like generic points that you can do this with. One of the very generic ones that every programmer loves to talk about is languages. We all have our favorite language, and we all know that the pros and cons and ins and outs of the different languages. And this is an example of a paper that basically rates languages regarding their energy consumption. So in the end, what does this mean? We choose like a new language for our next AWS service. And what are we going to go with? C++ is, I think, very well in this sort of environment, and it's something. So we're definitely going to choose C++. Minus is no one likes C++. All right, moving on. Down the list is Lisp. We could use Lisp. I mean, who wouldn't want to use Lisp for this? Again, maybe not the best choice, but even looking at the whole list, I think the picture is clear. Compiled languages perform better than interpreted ones. That's an easy one that everyone would have guessed that, right? So improving that is quite an easy catch. So, but yeah, we are usually we also want to have a little bit of this full stack feeling. So we might be in the JavaScript domain, but we're actually not doing JavaScript because we don't feel like this is safe. We want the scalability, so we're doing TypeScript. But wait, TypeScript? Why is TypeScript so much worse than JavaScript in this case? Because I mean, just looking at the numbers, JavaScript is about 4 or 5 times better than TypeScript? Does that make sense? I mean, isn't one just the transpiled version of the other? We might have to look a little bit deeper into that. So looking at the exact logic behind this, we look at the computer language benchmarks game, which basically was the means of evaluating this kind of solution. And in this case, we see, okay, Node.js performs better than TypeScript. I'm not sure what kind of thing TypeScript ran on, probably Node.js as well. But it performs better. But again, isn't it just the transpiled version of the other? And then you start even looking deeper, and then you're at the level of algorithms. And then you see, okay, the one source code uses threading, uses multiple CPUs, while the others doesn't. Of course, the one performs better than the other if you run it on a multi-threaded machine and the algorithm fits to that purpose. So yeah, this is one case where the discussion leads you to a very good point. So it doesn't matter where it leads to, but you want to have this kind of discussion. You want to dig to this level of depth because now you're talking about the efficiency of algorithms. You can even dig deeper. You can then talk about hash lists versus arrays and using these different sorts of algorithms out there to improve your energy efficiency. This is exactly the kind of level you want to talk about, and also something that usually engineers feel comfortable with. And this is also something that really takes them, because especially if they're in their own environment, then they grasp what they can do. They can really have an influence, and it might only mean to improve the speed of an algorithm a little bit, but they also see like the bigger picture, that it has a benefit in the sustainability area. And this is something really important for everyone. So after this like quick deep dive into programming languages and what you can do with them, I want to I know that within these 30 minutes, I'm not able to show like all the knowledge out there that you can do to improve yourself, to improve your company. So I just want to give you a couple of resources that you should look into, that you should maybe join or at least read up on a little bit. All of these communities are awesome for different purposes. ClimateAction.tech is a community really oriented towards exactly this topic. So looking at green software engineering and everything surrounding this is a Slack channel you can easily join, sign up within minutes, and you'll have a wealth of resources, discussion partners on exactly all the levels that you want. Green Software Foundation, really a foundation, part of the Linux Foundation that takes on a lot of the like norming and standardizing and kind of formalizing the ideas around green software engineering. They even currently, I think they still have a challenge going on, creating an API that helps or that you can use to run your algorithms at times that are better for energy consumption. So basically an API that you can ask whether it's now better or worse to kind of run your algorithms, because you know out there at night the wind blows, during the day the sun might shine, not so much in Berlin, but in general. And you can ask this API, okay, is it good to run now? And you might have an algorithm that just runs once per night. And it doesn't matter if it runs at 1 p.m. or 3 p.m. or any time in that frame. But it might make a huge difference regarding the energy and the grid and if it's green or not. And if you can ask this API and then run your algorithms accordingly, you can just improve it a lot. The other three, climate change AI, is something really looking into AI and green AI, because there you can imagine a lot of data is going on, a little bit less than in the whole crypto scene, but also a lot. LFC.Earth, if you're really looking to change your whole company, it's Leaders for Climate Action, which has guides to optimize a whole company. So looking from a corporate travel policy to how to have a sustainable team lunch. You have guides and guidelines for everything. And Climate Designers, for all the designers out there, if you that want to see what makes sense. Does it make sense to have a dark mode? Yes, it does. And which kind of image resolutions to use is also a perfect community. Regarding the books that I mentioned in here, I specifically want to highlight the Designing for Sustainability, because I think it encompasses all of these things that I just talked about and really can help you learn a lot in a very fast way about the whole topic. To sum up, just keep these 3 or 4 different points in mind: eliminate, utilize, allocate, and educate. And if you can bring this topic to others, really try to pick your chance. Because in the end, I think data is the new oil, and I think we are all responsible to not just build refineries again, but really think about where we can use data, what we can use data for. And if you want to talk to me about the details, I will be at the speaker's corner after these talks. Thank you.